In this lesson, the Taguchi loss function is superimposed with two other distribution functions and the loss shares are assessed. And hello again to this lesson in which we want to focus on one learning objective. In the end, you should have understood why striving for a target produces fewer losses overall. This lesson therefore consists of only one chapter. We will look again at the distribution function that results from good-bad thinking and the distribution function that results from striving for a target value. We then superimpose these functions with the Taguchi loss function and compare the loss shares. So let's start with the comparison of the loss shares of two value distributions. To do this, we build again a diagram starting with the x-axis for the diameter of the piston. The lower permissible limit of the piston is 60 mm. The upper limit of the piston is 60.2 mm. The y-axis scale is for the frequency of actually measured diameters of different piston diameters. As already discussed in one of the previous lessons, the values can be distributed evenly across the entire width of the tolerance if there are no other specifications, such as keeping the spread small. The result is a rectangular or uniform distribution. Instead of the individual values, the distribution is represented by a distribution function. The area represents 100% of all values. In this example, it includes all 44 values. This uniform distribution came about because there was no target value to which one was striving. Now we add a target value and the resulting distribution of these values. As before, each measurement result is represented by a value arrow. It can be clearly seen that the values are concentrated around the target value. These values are also described by a distribution function, which describes the distribution of the values optimally. The area under the curve represents 100% of all measured values. To make the picture clearer, both distributions are shown separately from here on. To briefly emphasize this again, the area under the two curves should be of the same size since they each enclose 44 measured values. These envelope curves have now been superimposed with the same loss function. Of interest is now the intersection below the loss function with the other distribution functions. This area is a measure of the size of the losses. It's still difficult to see here, but the losses are smaller if you try to approach an ideal size when manufacturing the piston diameter. That's the picture on the right side. The uniform distribution has now also been added to the right-hand side. The yellow area that is still visible is the part of the losses that occur less when you are striving for a target size. This is very clear proof that you should not use the entire available tolerance evenly, but always try to keep the spread of the values small and approach a target value. So, although this was a relatively short lesson, I would like to conclude by repeating the three most important key messages. When striving for a target value, the loss shares are the smallest. Striving for the target size reduces the risk of producing bad parts. And generally speaking, the losses to society are smaller when striving for a target than without. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care, and see you next time. Bye.